All right, in this lesson, for some reason, I don't have a picture of the back of this. But there's not much I need to do back there anyway, so we'll just talk about it when we flip it. Maybe I'll work some of the problems on the front with you. But anyway, today we are rounding off decimals. In the world of decimals, decimals sometimes can go on. You could do a problem sometime. Oh, that's nice and fat. You could do a problem sometime, and it literally could go, I don't know why that's there. It could literally go on forever. In fact, you know how you learned about pi, and pi is 3.14, okay? And what they figured out is that the diameter, if you took the diameter and multiplied it 3 and 1/7 time, you would get this pi. You would every circle is 3 and 1/7 of the circumference. That's what I'm looking for, the word, of your circle. But anyway, they have this pi. This number is just really rounded to 2 places after the decimal because it goes on forever and ever. And if I'm remembering correctly, if we, like for instance, the fraction 1/7, if we change that into a decimal, that would be 7 divided by 1. And this would go on, I think, forever. I mean, 7 divided by 1 is 1 divided by 7. Sorry. What you need, Ryden?
Can I get dressed and
Sit down and play with it. You can sit down and play and not run around too much. But you can do whatever. Make sure you brush your teeth and get dressed. 7 into 10 is 1. Yes, you do have to brush your teeth. 10 minus 7 is 3. Bring down another 0. 7 goes into that. What? 4 times? Oh, I'm still working. He's in here talking to me while I'm recording. 7 times 2 is 14. And you can see here how it's just like going on and on. Now it's 6. I might even be wrong because Ryden's talking to me. But anyway, my point being, it goes on forever. Pi goes on forever. They have just rounded it off to 2 places after the decimal and said, that's it. That's as far as we're going. Okay? So, like, for instance, if you're doing a multiplication problem or a division problem and you're doing money, well, you don't want to go past 2 places after the decimal because think of change. You know, it doesn't go any bigger than 99 cents, which is 2 places after the decimal. So we don't go any further than that. So if it goes any further, we just take it out 3 places and round it up to 2 places. So we need to get good at rounding decimals, and that's what we're going to do today. So if we look at number 1, we have 0.47 or 47 hundredths, but they want it rounded to the nearest tenth. So they don't want any more than one number after the decimal, because remember, in the world of decimals, the first place is the tenths. Next one is the hundredths. Right? So this one goes into the hundredths. We want it in the tenths. So you look at the number after it, just like we did in whole numbers. I have hiccups now. 7, we'll round that 4 up to a 5, because remember, 0 through 4 keeps it the same. 5 through 9 rounds it up. Okay? So it'll be 0.5. All right, so now in this one, we go into the hundredths, and we want to round that 6 there. The 2 is not going to change it. So you can simply just write 1.6. 0.88, so this 8 will do what to that 8? If you said round it up, you're correct. 0.29, what will that 9 do to that 2? Did you say round it up? 7.45, what will that 5 do to the 4? 7.23, what will the 3 do to the 2? Nothing. Okay, Now in this row, we're going to round off to the nearest hundredths. So we might have something that goes out into the thousands. They're not going to take it any further right now because you're just learning it. And we have to round it to the second place, the hundredths. So we look at the 9, and what will that do to the 2? Round it up. 0.463. What will that 3 do to the 6? Nothing. What will that 5 do to that 0? Make it a 1. What will that 6 do to that 1? Make it a 2. What will the 3 do to that 9? Make it a 10, right? Which in turn changes the 4 to a 5. That's a little bit tricky. And you want it in the nearest hundredths, so go ahead and write that there, even though it doesn't change the value any. But they want it in the hundreds. Say it was money, and you'd want that 0 there. We don't say money, $2 and 0.5. We say $2.50. All right, and this one, once again, this thousandths 9 will change that hundredths sign to a 10. Oh, this one is 250. You're like, Mrs. Kenny, here she goes. Oh, now I hit the wrong button. Once I start messing up, there's no going back. All right, let's try this. This was totally wrong. I think I was looking at the next one. I was looking at this one. What happens that 9 from that 3? Nothing. So this one would be $2.49. And then this one would be $2.50. And no, you don't need that dollar sign. I was just using that as an example. All right, so now down here when we divide, I'm not going to make you check. I never make you check. But we're going to divide and we're going to annex or add zeros until the problem terminates, which means until it's finished. All right, so let's watch. So 21 divided by 24, I can't even do that, okay? So I'm going to go ahead and what they call annex a 0. I'm going to go ahead and extend this out. Put the decimal up top too. Remember we learned that yesterday. All right, now 24 into 210. So it's on, I always think of 24 as really close to 25. I can get 4 25s out of 100. So how about 8 25s for 210? So 224 times 8, 16, 19 is probably as close as I can go. So I'm going to do 0.8, 192. Remember, I don't have to worry about the decimal down here. 0, then that's an 8, 1, and that's a 1. I have 18 left over. Go ahead and give it another 0 because we're going to keep going until we get a 0 in our remainder. So 24. So 8 was too big. Let's try 7. 14, 15, 16. Yep, so let's use a 7. 120. We're going to add another 0. Make it 120. 24 times 5. There we go. There's our 120. So our answer is 0.875. All right, let's try B. So 116 will not go into 29. It's too small, but never fear. We now know decimals. So put a decimal in that problem and add a 0. And now 116 will go into 290. Will it go twice? I believe it will. Double the 100 and we have 200. Double 16 and we have 32. So 232 if we go twice. That's an 8. I get 58 as my remainder. We're going to annex or add another 0. 116, I'm going to try a 3. 348. Will 4 work? I'll do 4, just 4, 6. 464 works. So now I'm wondering, should I do 5? Let's see what we get for 5. Oh, guess what? That's a perfect match. All right, so it's a 5. Okay? All right, 64 into 16. Add a decimal. Annex a 0. 64 3 times would be 100, or at least 180, because 60 times 3 is 180. So it must be twice. Let's double it. Can you double that in your head? That's 120 plus the 8, 128. And I get 32. Let's add another 0. Let's go ahead and try 5, just because it ends in a 0. Maybe we'll get lucky. Yep, there it is. Okay. How's that? All right, down below, that's really old stuff. Now, the back, which I don't have the picture for, looks pretty easy. I just want to go down and look at number 10 with you. And I will write these here, my blank spots. So we have n plus 6 equals, too bad I can't write down in that white stuff. N plus 6 equals 8 times 9. All right, so what should we do first? Yep, we should do the 8 times 9. So just bring the n plus 6 down and write that. Okay, make sure you're doing the steps. Now, whoops, now you can do minus 6 on both sides. Now we're left with n equals 66. Yeah, 66, not 64. There we go. Okay, let's see if it works. 66 plus 6, that's 72, equals 8 times 9, which is also 72. All right. I think you're good. I think everything else you guys could do. All right, I'm going to leave you go to do the rest of it on your own. And I think I'm going to quit this lesson here. It'll be just fine. Have a good weekend. Is this the last one? Yeah, I think this is the last one to go for next week. Have a great weekend, guys. And we'll see you next week.